Hi, I'm James Ward. I've been playing with some cool stuff with Spring and Kotlin and test containers, and just wanted to show you this cool stuff. So I'm going to create a new project here on start.spring.io. Pick Gradle Kotlin for the build, Kotlin for the programming language. Now let's go add some dependencies here. So let's add in our reactive web. Let's add in test containers, and then R2DBC for reactive database stuff, and Postgres for the database. Now let's generate that project, and there's my zip file. Let's put this on my desktop and go open it up. So here we go. We're going to open this in IntelliJ and then start writing some code. Okay, my project is now set up and ready to go. So let's come in here and start building an application. So I'm going to build a little database application to store customers. So the first thing I'm going to do is define a data class called customer, and that's going to have a ID. So we'll do @ID for that, and let's import that thing. And then this will be a val called ID, which will be a nullable long. And then let's add in a field which is a name, which will be a string. Okay, so that's my my item that we'll be storing in the database. Now let's create our interface to that database. So we use the interface, we'll call this customer repos, and this is going to extend the coroutine CRUD repository. We're going to store customer, and the primary key is a long. Okay, so now that's our database access layer. We do need to do a few things to get this working here with Spring. First thing is we're going to say spring.sql init mode equals always to make sure we initialize our data, and then we can create a new file in here called schema.sql, and we're going to create a table if not exists. We'll call this thing customer, and it's going to have a field on here ID, which is going to be a serial primary key. And then let's also have a name, which is going to be a text, and we'll make that not null. And that's it for my SQL. So now let's go check out let's write some tests for this thing. So the first thing I'm going to do is come over into my test demo application. You'll see that the start.spring.io added in this test configuration bean. I'm actually going to take this and move it so that it'll work with my unit tests here. So let's just pop that thing in here. And now let's write a test for our database access. So here in this test that it's already created for me, what I'm going to do is say run blocking. The reason for that is that we want to block these tests. They're reactive, so normally they would be non-blocking, but for the sake of a test, we want to actually run this in a blocking context. And so then let's, first thing we want to do is create a customer. So let's just create here a customer, and let's give this thing, it doesn't have an ID yet, that's going to be created by the database, but it does have a name. We'll give it a name, James. And then we do need to, in here, inject into my test stuff that customer repo. And so one way that we can do that is just auto wire in here the customer repo. And so now that'll get wired in when we run the test. And now let's use that customer repo, and let's just call customer repo.save and save our customer here. Okay, now that should be saved to the database. You'll see that that's using coroutine, so all non-blocking reactive stuff underneath the covers. But now let's actually check and make sure that this worked against our database. So let's come in and get our customers out of the database. So we're going to use our customer repo now and say just find all. And then let's do an assertion. So let's do an assert. Can we do assert true? I think that should be, there we go. Yep, let's import that. Oh, we got to pick the right one here. Let's do JUnit, sure. assert true. And then our assertion is going to be that customers dot, this is a flow, so it's like a stream. We're going to get the count of the number of items that transforms the stream into a coroutine. But then we're going to make sure that this is, let's just check that it's 1. Okay, so that's our assert true here. And it looks like I did use the wrong assertion. Thank you, IntelliJ, for fixing that for me. Okay, so now this will set up our test containers, Postgres container for us to run our tests in, but we do need to have a place to run those containers. I'm using Testcontainers Desktop here, and I'm telling it to run those containers actually on Testcontainers Cloud. So pretty cool. I don't need to set up any Docker stuff. Okay, last thing is I moved that, so let's recorrect that. Okay, so now we should be able to run our tests. So let's just give this a try. We'll hit run on our tests here. And now we should verify that sure enough we can create a customer stored in the database that should get a primary key assigned to it. We didn't write a test for that, but certainly could. And then we're going to make sure that our database has that customer in it. So that'll take a second to spin up here. Should start up the database container, run our tests against that container that's going to actually run on Testcontainers Cloud, and yeah, it should all work. So we'll give it a second here to finish compiling and setting everything up, and we should be good to go. Okay, looks like that all ran, and we can look through the logging here and see that sure enough it ran that Postgres test container up on Testcontainers Cloud, and then it ran our test and our test passed. So all that worked as expected. That's great. So now the next part of this is to get our REST application set up so that we can have a REST interface to this thing. And so let's go over to our demo application here, and what I'm going to do is create a new bean here, and this will be defined by a function. We'll just call it HTTP. And I'm going to use something in Spring called the co-router, which is a nice way to define HTTP routes for a Kotlin application in Spring. And so now let's do a get handler for slash. And what I'm going to return on a get is going to, we do need to inject in our customer repo. So let's put this in here. We'll call this customer repo. There we go. So we'll inject that thing in. So now we should have our customer repo, and we can say find all. So that will now return that, but we do need to wrap that into a server response. So let's say server response, and this is going to be OK. And then what we can give it is the body value that we want to return. So this is, we can do a body value in a way if we have a specific value, or we can say body in a way if we want to give it a flow. So because we're doing a flow from find all, that's the stream, so it'll be a non-blocking stream through HTTP through to the database. Then what we're going to do is get a post handler here for slash. So when we make a post request to slash, we can now have a function that's going to get the request. So now what we want to do with our request is get our customer that was sent over and will be deserialized from JSON. So let's call this thing customer, and we're going to take our request. We're going to await the body of the request or null, and the reason is that if we can't deserialize this into a customer, then we want this thing to be null. So that will do our non-blocking coroutine await on that request coming in and deserialization to a customer. But now let's check our customer, which is a nullable customer, and make sure that it's not null. And in the case that it's not null, what we want to do is actually save this thing to the database. So let's do that here. So let's take our customer repo and let's save this customer. And you'll see the smart cast where we've checked to make sure that it's not null. And so normally this save method can't take a nullable thing; it has to be an actual thing. So we smart cast that customer as a non-nullable customer. Okay, so then we need to return a server response. So let's return, usually in this case, we return a no content, and then we can do a build and await here to get that response back. And my scroll bar keeps scrolling too much, but here we go. Now let's put in our else. So if for some reason that customer was null, so it couldn't be deserialized, let's just do a server response with, I don't know, bad request for now. And there we go. Okay, so that's my server implementation, my REST server implementation with the get and the post. Now, one of the cool things in Spring is that we can now run our application with the test containers. So we just come into the test directory where our test stuff is, and you'll see there's this main and test that now we can run. And when we run this, this will spin up our test container for our Postgres container and run our Spring application pointed at that test container. So pretty nice way to have kind of a dev experience, not just the test experience, when we're using test containers as well. Okay, so that looks like my application was started. Let's go now over to, should have a little HTTP handler here to make some HTTP requests. So let's come in and make our GET request, and we should see that, all right, our first GET request, we get just an empty array back. So let's go now make our post request with our JSON. We're only sending the name. ID is nullable because that gets created by the database. There we go. Now our response body, it was no content, so that's great. Looks like it was saved to the database. Now we can come in, run our request again. Now we, sure enough, get an array with one item in it. You'll see that they got the ID primary and key assigned to it, and there we go. So that was just a super quick run through of some cool new stuff with Kotlin and Test Containers Cloud. So anyways, yeah, check it out and let me know what you think. I think there's some pretty cool stuff here. Thanks for watching.